Here we are going to discuss about the moment of inertia of uniform disk. I have taken a uniform disk. As you can see that this is the side view of this disk, and mass of this disk is m, which is uniformly distributed. The radius is r and thickness of the disk is negligible. Okay, this thickness is negligible, and we want to find out the moment of inertia about this axis. This axis is perpendicular to the surface of a disk and passing through the center of a disk, right? And this is the top view of this disk. So now disk is having a continuous mass distribution, so we will use the integration method. So what we will do, we will calculate the di, right? Di will be r square dm, okay, or whatever. We will calculate di, we will calculate the moment of inertia of elemental mass, and then we will integrate it, and using the integration we will calculate the total I about this axis. This will be our approach for this question. Now I need to consider some elemental mass. Okay, so I need to consider some elemental mass, and as you know, we have done the calculation for the rod, for the ring. So we have taken a point mass. Okay, but if I consider a point mass here, the problem will be the r and theta both will be variable for that. Okay, r the distance and second the angle from the x-axis, right? So to avoid that, I will consider a elemental ring. Okay, I am considering a elemental ring. Okay, so like this. Okay, yeah, we can assume this disk to be formed by the combination of multiple rings, right, starting from this point, okay, up to capital R, starting from r equals to 0 to capital R, right? Now we know the moment of inertia of the ring about the axis passing through the center. We have discussed in last class, right? So like this is our elemental ring, and this is the axis of rotation. Okay, and axis is perpendicular to the surface, so axis is like this, right? And let's assume that the mass of this elemental ring is dm. So then we know that the di will be di of this elemental ring. Let me write down here. Moment of inertia of elemental ring will be, because for the ring it is mr square, right now the mass is dm, so it will be dm r square or r square dm, where r is the radius of this disk. Okay, we are assuming that the thickness of this ring, let me draw it again. The ring is like this. Yeah, so this thickness of ring is dr. This thickness of this ring is dr. So we will define the dm in terms of dr so that we can integrate it. This is our di. So dm would be the surface area of a ring multiplied by surface area of the ring multiplied by the surface mass density. Why we are considering the surface mass density? Because disk is a 2D mass distribution. Okay, so dm will be sigma multiplied by d, where sigma is areal mass density. So let's first calculate the sigma. Sigma from this disk will be total mass divided by total area, right? So it will be m divided by pi r square. This is sigma, right? So the mass of this disk will be dm is equals to sigma multiplied by dA, and dA is the surface area of this ring. Okay, so if I take this ring and if I cut it from somewhere like this, so then I will get a rectangle like this. the length of this rectangle will be 2 pi r, right, and thickness of this rectangle is dr, so then the dA will be 2 pi r dr. I hope you are getting it, right? So dm is sigma multiplied by 2 pi r dr. So now let's substitute over here. So we are getting di, that is r square, and dm is sigma multiplied by 2 pi r dr. Okay, so di will be 2 pi sigma r cube dr, right? Now we want to find out the total I. So total I will be integration of di. Why integration? Because we are assuming that this disk is formed by the combination of multiple rings starting from r equals to 0 to r equals to 0 to r, right? Okay, so we will integrate. So that is 2 pi sigma is just a constant, so let's take out from the integration. So 2 pi sigma r cube dr, and integration will be from lower limit to upper limit. So lower limit will be the starting element, and we will start from the r equals to 0. We will consider a elemental ring at r equals to 0, okay, and the last ring will be at capital R. Okay, so I will be 2 pi, and sigma can be written down as m divided by pi r square. Okay, and r cube integration is r to the power 4 divided by 4, and limits are from 0 to capital R. Okay, so it will be let's cancel out pi. So we are getting 2m divided by r square multiplied by r to the power 4 divided by 4, and lower limit will be 0. Okay, so we will be getting r square, right, and this will be 2. So we are getting m r square divided by 2. So we have got one formula. You can memorize this formula. So I is m r square divided by 2. This is the moment of inertia of a disk, but it's important that about which axis. Okay, so the axis is passing through the center and perpendicular to the surface. So this is the moment of inertia.